Right, quick chat with 305 marks and 320 marks. Should have had those back. Ahmed went through all 80 assignments and marked all 80. So he was having kind of, he was going mark crazy by the end of it. He said if there's an issue, speak to him, either go to Sigma or drop him an email and he will have a chat to you about it if there's an issue with your mark. The problems he found was a lot of people's work, they probably did lots of work, but because the login didn't work on their web service, he couldn't test it. And that said, most times when he marked lower than people thought it was going to be, it's because he couldn't log in, he couldn't create an account, he couldn't log into the system. So obviously if you can't log in, you can't see a lot of the functionality, you can't see the posts and the puts and the deletes. So the moral of the story is just keep making sure your web service works before you and your client works all the time. What we're going to do today, we're now on session 3 of the third and final assignment. Now what we're doing is, there was a complaint from a computer science student that the work was too hard and they couldn't cope. And there was too many assignments. So what we've done, we've dropped the assignments to 3 rather than 4. So we've reduced the number of assignments to 3. And because of that, we've had to change the weighting slightly. So what we've tried to do is not mess too much with the previous 2 assignments. So we've upped them to 30% each. So the first 2 assignments were 30% each. And this assignment's worth 40%. Okay, that should help you massively get a good grade for this module. Because this assignment is probably the easiest of all 3. And what I'll also do is I'll extend the deadline on this one by a couple of weeks to give you a chance to get things nailed on this one. And this year, the last summative assessment. Yeah, I'll add a fortnight to the deadline, so it'll be the beginning of March, won't it?
When's the sessions?
Today, luckily for you guys. I can't remember exactly, but it should be on the Moodle. Should be on the Moodle course. Now, the final, after we've done this 6 weeks, the final 6 weeks, we're going to focus on Amazon Web Services. Now, really, really, really important. You know the guy who came to talk to 387 yesterday? He's hosted, we've got a commercial project coming in, and that's being hosted on Amazon Web Services. That's what his host's going to be. He phoned me up last night to have a chat. So in other words, if you do any work with smartphones or web apps or web services, the chances are you're going to be hosting it on some cloud system somewhere. And the choices are really Google Web Services or Amazon Web Services. Now, if you're doing 321.com, you're doing the Google Web Services, Google App Engine, those sort of things. So you're already covering that side of things. We're going to cover the Amazon Web Service, S3, EC2, database, in the last 6 weeks of this module. There's an assessment for it, there's an assignment. It's not part of your summative assessment. In other words, I'd love for you to do it to learn how to do it and get some feedback on it. And if you do the work, we'll give you feedback, but it won't count towards your final grade. It's more for those of you who want to go and do work in this area. It's the sort of thing you need to know about, or you need to be comfortable with. And the assessment's in there to give you formative feedback. So in other words, to make sure you're doing it right. You're doing it properly. And if you do that last piece of work, that will set you up for a job doing web service development, doing mobile web apps, doing native apps, that sort of thing. Okay, so it's important, but it means the last 6 weeks you're not panicking about grades and assignments, assignments being perfect. It gives you a chance to just try things out and learn. Now, we've covered Linux, and we've covered setting up the database, haven't we? We did MySQL. And I was actually quite impressed looking around the labs. Everyone's getting on with the work really well, and you're learning quite a bit. And if it fails, and you have to do it again, it's called learning, yeah? It's called practice, and you get to get better and better at this. What we're going to do today is talk about some more topics. We're going to talk about how web servers work, because I've discovered that not all of you have done 250, which is the systems architecture, network systems architecture, I think it is. So I need to give you a quick overview of the different OSI levels, layers that affect us. I'm going to show you how to build and configure an Apache web server. We're going to look at how to work with Apache Modules, because a lot of Apache is modular. You need to know how to install modules. And we're going to look at SSL and virtual hosting as the advanced topics for today. Could you shut the door for me? Would you? Okay, so this is a kind of 10-minute recap of what you'd have covered if you were doing 250Cte. Okay, now you need to understand a little bit about what's going on to understand how the Apache web server works. So I'm going to a sort of potted version of the different systems. Basically, have you heard about the OSI, the Open Systems Interconnection model, where you have the physical wires and you have these different levels? If you've ever done any Cisco work or if you've done networking for any description, you've come across OSI. OSI, it builds up a system, a network system in different layers. And each layer has a role, has a job. We're not going to do all 7 layers of the OSI because that would take a whole session. We're going to focus on the 3 that matter to us as web developers. The first one is the network layer. Okay? And the network layer, we see the network layer as the IP protocol, the internet protocol. Okay? The second bit we're interested in is the transport layer, which involves TCP, and that's the protocol we use at the transport layer. And then also we're going to look at the application layer, and there's quite a lot of protocols in that layer that we're interested in. We've got HTTP, okay, you're comfortable with that idea. FTP, we've used that. POP, for email systems, and SSH, how we connect it to our servers. And that's part of the application layer. So we're going to very quickly look at those different layers and how they build up, and then you'll have a better understanding of how Apache works and its job. Okay, so the IP layer, Internet Protocol, is all about connectionless communication. So it's all about how do we send data from one place to another place without a permanent connection between the 2 nodes. So the internet's a good example of that, isn't it? Where you have lots of servers, but you haven't got permanent fixed connections between these different servers. So, John Philippus, networking guy, he calls it the optimistic protocol. There is no error checking. It sends the message out and just kind of forgets about it. So there's no check to make sure the data's arrived, the data's got there, the data's been received, the data's understood. It just kind of is optimistic. It sends the data out across the network in packets, and then that's it. That's all IP does. It does message forwarding. So in other words, instead of going straight to from one place to another, it will bounce across different servers on the internet to get to its destination. And it has host addressing. Each node on the network has a unique address. Now we've been using something called IP version 4 with our systems. These IP addresses where you've got these 4 numbers separated by dots. The trouble is we're running out of addresses. The last couple of years we've been desperately short of IP addresses because there's a finite number of addresses. There's 256 to the power of 4, isn't there? Possible IP addresses, and we're running out. So they're introducing something called IP version 6, and that uses a ridiculous length of IP address. And if you look at your Config File, you'll see both IP addresses. You'll see the version 4, which is the 4 numbers, and you see a really long one with dots in it, which is in hex, and that's the IP version 6. And we're gradually migrating from version 4 to version 6. And I'll be locking this door in about a minute. Okay, so IP is all about sending data, we're using packets from one place to another across the network. Okay, the next layer up is this TCP. And often in the same breath you'll hear people talking about TCP IP. They're actually 2 different protocols doing 2 different purposes. The important thing is TCP is pessimistic. The TCP protocol assumes data isn't going to get there. So what that does, it checks to make sure the data's arrived. So what it does, it has error correction built in. So when packets arrive, it has a checksum to make sure the packet's still intact, to make sure everything's there. So it assumes there's going to be a problem with the network. And it allows data to arrive in any order. Okay, so data can arrive in any order and it will reassemble it at the destination. And if it's missing packets and it times out, it will simply request the same packet again. So it will resend packets of data across the network. So you can see how IP is the kind of the protocol to get pass data around, whereas TCP is the way of ensuring the data arrives. And it makes sense. So that's TCP. On top of the IP layer, and on top of TCP, we've got HTTP. And we're really interested in this protocol. This is the one this is the foundation of the World Wide Web. And this is a request response protocol. And it uses what's called a client-server model. So in other words, the client sends a request for something, and the server responds. There it goes. So the server sends a request for something, okay, across the internet. And what the client does, so the server responds with the data that the client's requested. So does that make sense? So it's a client-server model. And again, because it's using IP, remember, it's on top of IP, it means any missing packets get resent. So the request response model is the important model we need to think of. Okay, now, importantly, there are two features of HTTP. There are nouns and there are verbs. Now, this should be really familiar if you've done the first assignment, shouldn't it? You're familiar with the idea of URIs or URLs, unique identifying resources, and the actions are described using these methods: post, put, get, delete, and you've got head, you've got, what else is there? A few more up there, okay? So the important thing is that these protocols, these sit on top of each other and establish the connections that we need. And here's an example of a request. And again, if you've used API-G, you're completely familiar with these requests. Okay, we're back to lecture 1, aren't we? Okay. You've got two choices with this lecture. We either record them and the door gets locked when the lecture starts, or we scrub the recording and we let people wander in late. Okay? And we'll go back. I'll go back to Christina on this one and say we've got to make a decision on this, because I'm not happy with people walking in late on this. Okay, so there's the method and there's the file, the resource we're trying to access. There's the host, so the combination of the host and the resource gives you the URL. And every time we send a request to the server, we pass it certain information. We tell it which version of HTTP we're using, which is 1.1. We tell it what language the client's using. So if there's different language versions, we can send different versions back. Also, look at this. We say the client supports zip. So in other words, if the file's big, the server can automatically, the Apache server will zip the file up and send it a compressed version to the client, and the client can decode it. Okay? A connection keep alive basically means this isn't a one-off request, we're going to be sending more requests from this particular host. The important thing about this is it's stateless. So each request and response is handled completely separately. There's no understanding of what the device is that sent the request. Each one is handled independently and then it forgets about it. Okay, so what is a web server all about? Okay, the web server is all about using TCP/IP to transmit data across the internet using HTTP. That's all it does. So all it does, it listens on a particular IP address on a particular port, and whenever it receives a request, an HTTP request, it simply looks at the request, reads the headers, and carries out the instructions. And that's all it does. That's all the Apache web server does. The only complication is if the file it requests has a certain file extension, it will call a server-side scripting parser and it'll run the script before it sends it back. But most of the time it simply listens to the IP address and port and then responds to the request. So it's a really simple process. Now, when we talk about ports, a computer listens on what are called ports, And a port is effectively a slot that can listen to on a particular IP address. So if you don't specify a port with Apache, it listens on port 80. If you connect to a computer using FTP, it's port 21. If you connect using SFTP, it's port 22. If you connect over secure socket layers, it's 443. So these are just simply places where the computer's listening. It's listening to particular ports. So why Apache? Apache is one of the very, very first web servers ever developed. It traces its roots back to 1995. Now remember, the World Wide Web was created in 1994. Okay? And Apache, the name Apache, the official line is the Apache, the Native American Apache tribe. But the in-joke is, it was a patched version of the original web server, hence Apache. Okay, so that's the second reason it's got its name. And it's completely open source. It's maintained by the open source community. There's no commercial angle to this at all, which is why it's free to download. You can download binaries, you can download the source code. It's completely free. It's maintained by the Apache Software Foundation. That's just an overarching organization to make sure things work properly and everyone's doing the job properly. And it's the most popular and secure web platform you can get, web server you can get. It's completely cross-platform, which basically means it will run on any computer. And I literally mean any computer, because you can download the source code. So if you want it to run under BSD or OS2, as long as you've got a C++ compiler for your platform, you can compile Apache. When the Raspberry Pi came out, it's one of the first tools to be ported over. They just ported GCC, the compiler, to the Raspberry Pi, and from that point onwards, they could just compile any package. So it's the most popular server. I think it's got about 3/4 of the market share in terms of online internet-hosted sites. Okay, now, important concept of Apache modules. When it comes out of the box, all Apache can do is listen for files, listen to requests, and send files back. That's all it does. There's no scripting support in it. There's no support for particular file types. It's just HTML, responding with HTML pages. To get more functionality, we have to install modules. And these are compiled modules, which, when you install Apache, you get a whole load of them available, installed on the server, but not available for Apache. So we have to install the ones we want to work with. And there's all sorts of cool things. Your server-side scripting. If you want to use Perl or PHP or Python, you have to install the Apache module to enable that. If you want to do authentication, say looking at OAuth or token-based, okay, there's modules for that as well. And there's also different compression algorithms. Remember I said about zip? You can install the zip module for Apache, which means you can zip files up and send them back compressed. There's hundreds of modules available, and it's quite easy to write. They're written in C++. So let's go through the process of how we install Apache. Okay, now, if you think about what I've just talked about, the list of packages you have to install makes perfect sense. We've obviously got to install Apache, the web server itself. If we want to use PHP support, which we do, PHP 5, we must install PHP 5 itself. Makes sense, doesn't it? We have to install PHP. And if you want for PHP to talk to MySQL, we have to install the MySQL module for PHP. So Apache, we need PHP to run under Apache, and we need MySQL to run under PHP. So we have to install those 3 modules to get this thing to work. Config file, forget that one, I'll talk about it later. Right, okay, so that's it. You install those modules and Apache is now working. So all you have to do is put in your IP address into the web browser. Because the web browser is a client which sends HTTP requests on port 80. That's what the web browser does. That's its job in life. So as soon as you type in that IP address, it will send an HTTP request, okay, to the server on port 80. And if you've installed Apache properly, you should get a simple page appearing. Okay, which means you've successfully installed Apache on your server. And that's it, that's the basics of installing Apache. It's so easy. Now, if you start installing modules or something goes wrong with Apache, you're going to have to restart it. Now, there's two ways to restart Apache. You can call the service command, which looks at all the running services, to find the Apache 2 service and restart it, or there's a special folder called init.d. Init.d is incredibly important. Init.d is the stuff that loads when you boot up your server. So anything that's in that folder gets run when the server boots up. Not when someone logs in, but when the server first boots up. So you can see that Apache 2 is installed in the init.d folder, which basically means when you boot up your Raspberry Pi, it will automatically try and start Apache. Now, if you think about that, you can use that to your advantage. In week 6, when we do scripting, if you want your bash script to run when the server boots up, you simply save your bash script in the init.d folder. And if it's in there, it'll run when the server loads. And we restart. Okay, now, you may get this error message when your server starts. The problem is, I think that by default, the config file doesn't specify what the server name is. Because obviously, if you've got a domain name you're going to attach to your server, you're going to use that as your server name, aren't you? But if you haven't got a domain name, you're just using the IP address, you put the loopback in there. You simply put that at the end of your config file. And that says to the server, just use whatever IP address the Linux server is using. And that's called a loopback address, which basically means just refer to the IP address of the server. And that will fix that particular error. It doesn't affect the way it works. It still works fine. It just gives you that little error every time you restart, which can get annoying sometimes. Now, as you dip into Apache, there's one particular command which you will find incredibly useful, and that's Apache control. And that allows you to do all sorts of stuff to your Apache server, and if you want to find out more about this, just look at the manual pages, okay? But incredibly useful command when you do the more advanced stuff. Now, remember last week when we talked about permissions and users and groups? Remember that? We spent a lot of time on this. This is a precursor to today's session. Because the whole of Linux is based on users and groups, Apache has to run under a user, otherwise it won't have access to anything. So if Apache is running under a particular username, you need to know what that username is, don't you? Well, there's a file called nvars, and in there it'll tell you what the username is that Apache is using. Now I believe it's www.data is the username Apache is using. So you can treat Apache just like any other user. Now when we set up, and there's also a group called www.data as well for the Apache. So on the creative server, what we've had to do is we've had to give the www.data user access to your groups. So if you were to look at who has permissions on your particular group, you'll see that that user has been added to your group, which means that Apache can see your files and run your files on your web server. Does that make sense? If Apache wasn't a member of your group, then it would never be able to run any of the scripts that are in your public HTML folder, because it wouldn't have permissions. Unless you gave everyone permissions to run scripts, in which case it becomes very insecure, doesn't it? So what we have to do, you have to think about how is this user going to access the files in the folder it needs to run? Does that make sense? It needs permissions. So when you add a file to your web server, the owner of that file is you, and the group is your group. But this user has been added to your group. And that's how the Apache server can run the stuff in your public HTML folder. Okay, the alternative to that is we make the group for your files www.data. Okay, but that was more work, and that was trickier, so we didn't do it. So basically, think about if you says page not found or permission denied, the chances are that particular user hasn't got the right permissions for your files on your web server. And that's what you need to be doing, checking up on that user. Now, when you first install Apache, it creates one website for you, just one. And the files are in a folder called var www. Right? So basically, if you open that folder up, you will see one file called index.html. And that's what you saw when you typed the IP address into the browser. So if you want to serve a website from your server, all you've got to do is create your website in that www folder, and that will create your website for you. Now, any problems, Apache will log the information, will log the errors for you, so you can see what the problem is. So if something happens like it doesn't start properly, or it's not serving the pages, you get a permission denied, you get a 404, you get a 500 error, the best thing to do is have a look at that file there, the var log apache 2 error.log. Are you getting a feel for the folder structures on Linux, by the way? Is it starting to make a little bit more sense now? So you can see, look, there's a log folder, so any logs are going to be in that logs folder. Apache 2 is the service, and there's the log file. Useful command, another useful command for today, cat. What cat will do, it will show you the last few lines of a file. Yeah? Does that make sense? So if you cat that file, it will show you the last couple of entries. I think it's the last 10 entries by default. And if you think about log files, that's exactly what you want, isn't it? You could load it into Nano, but there might be megs and megs of log files in there. Then you've got to scroll to the bottom, page down, page down, page down. Cat just gives you the last 10 lines. So if any errors occurred, you can very quickly spot the error. Linux has been written by lazy people, for lazy people. That's what it comes down to. If it's something you need to do, there's probably a very quick shortcut to do it. Now, PHP. If you've done everything properly, PHP should be enabled. How do you know it's enabled? You simply create a PHP file and stick it in your web root and run it. Think about it. If you create a file called index.php and put your IP address /index.php, it should load the PHP file. If you see the PHP script itself, it means PHP is not working properly, doesn't it? It just means it's simply giving you the contents of the PHP file. If you get the script running and you get the results of the script, it means PHP is set up properly. And always, always write a little script to run Phpinfo. Phpinfo gives all the settings of your PHP interpreter. And if you run that properly, you get something like that. That's what your web page should look like. Look, it tells you the version, it tells you the system, it tells you the all the features, all the ini files it's loading, everything about it. Yeah? You see what I mean? So if that page loads, if you see that page, it means PHP is working. So you're ready to start transferring your files across and getting them running. So that's a really useful command. Yeah, Phpinfo. There's a PHP config file, so if you need to look at it for any reason, you shouldn't. It's at etc. PHP 5, Apache 2, PHP ini. That's your PHP config file. Is it running out? Okay, so we've talked about installing Apache, and we've talked about the idea of Apache running as a modules. Of course, your assignment, you're going to have to install a module. Yeah, that's kind of made sense, isn't it? Yeah, I wouldn't let you get away without installing modules in Apache. So you're going to have to install an Apache module. So I'm going to show you a couple of features that you need to be aware of when you do this. I can't spell functionality, but apart from that, okay, the modules that are currently enabled are in a folder called mods-enabled under Apache 2. Remember I said everything on Linux is files, isn't it? Files, files, files all the time. Well, there'll be a set of files in that folder, and they are all the modules that are currently enabled with Apache. Okay, now, so if you want to see which ones are installed without going to the folder, remember Apache 2 control, M flag gives you the list of modules that are installed. Makes sense, doesn't it? M for modules. But if I look at that folder, and do a list, detailed list, what do you notice? There's something very odd about that listing. What's going on? Look at the file names at the end of each row. What's it telling us? That's the name of the file. What's this thing all about? What do you think it's trying to tell us? Gosh, hazard a guess. Yeah, right, they're shortcuts. Yeah, I've created shortcuts. That is a shortcut to that file. That's a shortcut to that file. So the files never move to the mods enabled folder, or they stay in the mods available folder, and we simply create shortcuts to them. Okay, that's kind of cool, isn't it? So the shortcuts, we create shortcuts to the modules. And the name of a shortcut in Linux is a symlink, symbolic link. You may have come across them before. Symbolic links are all about shortcuts. But unlike Windows shortcuts, where you go to a folder and it's obvious it's a shortcut, in this one, when you list the file for the contents, the computer thinks that's the file. It treats it completely the same as if the file was in the folder. Okay. So, shortcuts. And if the detail view tells you where the shortcut points us, generally, see that sort of cyan colour? If you've got colours enabled, cyan is the colour for shortcuts, for symlinks. So if you see any files in cyan, it means they're symbolic links. The files don't exist in that folder. And the other way to prove it is, if you look at the file size, look how tiny the file size is. 8 bytes. 8 bytes is the size of a symlink. So even if you're not sure if it's a symlink, if you look at the file size and it's set to 8, you're pretty sure it's a symlink. Now, did you notice there were 2 files for each one? There's the program file, you see the actual library, the module, and there's a config file. And that's because, of course, when you install modules, you want to configure them, don't you? Tweak the settings. So every single module has a built-in config file for itself. So when we create the symbolic links, we're actually creating 2 links for each module. And if you want to mess with the settings, the configuration, you can edit the configuration file. And that's exactly what you're going to be doing for your assignment. You're going to be tweaking the configuration. To install modules, you haven't even got to create the symbolic links. A to N mod, and then the name of the module. Then restart your server. Okay, easy, isn't it? Yeah, working with Apache modules. Okay, now this is why I want you to use an Apache module. When you use Creative, you've all got your server space, haven't you, with a little tilde sign and the username. So every single one of you's got your own web root. But by default, Apache doesn't give you that functionality. To do that, we have to install an extra module. And the module we install is user dir, user directories. You install user dir, you tweak your config file, and you've got personal folders, personal web folders for every single user. And that's what a config file looks like. It's XML. It's a simple XML file. And this is how it looks. And can you see how this is working? This is the same config file we use on Creative. Okay, now, use the IR public underscore HTML. That's the name of the folder we expect to find. Yeah, remember we had to create it ourselves. Root doesn't have this. That would be a massive security issue, wouldn't it, if root had its own web folder. So we don't allow root to have a personal web folder. It makes no sense, and it's a security issue. Directory /home /anything /public underscore HTML. So that's what it's looking for. Yeah? And you can have anything. You can have any folder name you wanted. You can have any subpath. These are the settings. Allow override file info. Allow override allows you to have .htconfig files. The important thing is, please remove that. That is really important. If you leave that in, you can't execute any scripts in your home folder. It simply serves static pages. It's a security feature. So by default, PHP is not enabled in your home folders. If you remove that option, you can run PHP scripts in your home folder. Okay? And limit except basically says you can only do get, post, and options. They're your methods. So again, you may need to tweak that. Hint, hint. Yeah, when you start working, if you decide to use that the user's public folder. Order, deny, allow. Deny from all. Okay. Deny means it denies to everyone, and then it allows to certain people. That makes sense. So you could have, if it was off order, allow, deny, it would allow everyone to use it apart from the blacklist. This one says allow no one to use it apart from the people who are supposed to use it. So that's what deny, allow means. And deny from all basically means the only person who can access that folder and put things into that folder is the folder owner. Makes sense, doesn't it? But again, if you want to tweak any of this, the great thing about Raspberry Pis is no one's going to scream at you if it goes wrong, apart from yourself. Yeah, when you go, and the worst case scenario, you just have to reinstall. Okay, so by all means, but if you're going to change this, I would recommend you back it up. You copy and paste, make a copy, keep it somewhere safe, just in case you need to go back to it. You can even use, yeah. So I just simply, make a copy of the bits you changed to make sure you're not, you can go back. Now, advanced topics. I think we're going to be perfect today. Right, advanced topics. There are two, if you want to get 4 or 5 for this particular task, there are 2 things I want you to look at. One is SSL certificates, and the other one, the ultimate one, is virtual hosting. I'm going to talk about SSL certificates in some detail because it's quite difficult to get your head around. Virtual hosting I shall talk about briefly, but I shall not be telling you how to do it on these slides. I'll be giving you enough hints and clues of how to do it, but I won't be telling you how to do it. So if you want to go for the high grades, it's a bit of investigation is required for this. Secure socket layers. The problem we've got is when you pass data, you make requests and responses, it's all plain text. It's just text being passed backwards and forwards. It's in packets, but the packets bounce, remember, from server to server. At any point in that route, someone could sniff those packets, could actually read the contents of those packets. And if you're sending usernames and passwords across, then potentially they could read your username and password and intercept it. Which, if you're Amazon, is not a good idea, is it? Yeah, it's a problem. So, the solution is to encrypt the data, isn't it? So you use a key to encrypt the data, you pass the data encrypted across the internet using HTTP over TCP/IP, and then you decrypt the data at the end. Okay, and everyone's happy. So what you do, you have a key which you use to encrypt the data, and then you use the key to decrypt the data at the other end. Anyone see a problem with this? The key has to be on both ends, isn't it? So somehow you've got to pass the key over an open connection and hope it doesn't get intercepted. So using this standard encryption isn't going to work, is it? Because if you go to Amazon, Amazon would have to send you over plain text their key to allow you to decrypt the data packets going backwards and forwards. So for a long time, this caused problems. Until one day, some mathematicians came up with a solution to this. Okay, so the problem is basically, as you can see there, that we've got to, if you use standard keys, the same key to encrypt and decrypt, you've got to pass the key across. So that's why, if you look at things like the Enigma things, once they have to pass the keys to the U-boats to all the units, and that caused problems. You have these little encryption pads, and that's the weak link in the chain. So let's have a look at this. We're going to use something called Secure Socket Layer, SSL, to do our encryption. What this does, it's very clever. There are two keys. Okay? There's a public and a private key. They're mathematically linked together, but they're not the same. And knowing one key doesn't mean you can find the other key. Okay? So if someone intercepts one of those keys, they can't calculate the other key. And the idea is, we encrypt data using the public key, and we decrypt the data using the private key. So it's a one-way system. So once you've encrypted the data with a public key, you can't then decrypt it with the same public key. And the private key can only decrypt data, it can't encrypt data. So each key does one job. Can you start to see how this is going to work? How this is potentially working? This means every party, the client and the server, can exchange their public keys quite happily. It doesn't matter. Because all the public key allows you to do is to encrypt the data. Nothing can be decrypted apart from with the private key. So this gives you a really nice secure connection between the two systems. There's only one issue with this. Let's imagine I connect to what I think is Amazon, and I get their public key, and I encrypt my credit card details using that public key. If someone's spoofing the website, they could potentially intercept that data, pretend to be Amazon, pretend to be eBay, and capture your public, capture your credentials and your details. That's a problem. So we have to have a solution to this. And the solution is certificate authorities. You know, when you connect to Amazon, it doesn't question the certificate, does it? It doesn't say, oh, it's a new certificate. That's because VeriSign have verified the Amazon's public key. And not only that, but your browser already has that public key installed. It's already there in your browser. You know, when you run browser updates on your system, when you have updates for Explorer or Firefox or Chrome, it's actually downloading the extra public keys for the known websites. So when you connect to Amazon, your browser already has the key. So there's no issue, there's no keys transferring at all. But for this to work, you have to have a trusted company to guarantee that that key comes from Amazon. And what Amazon do, they pay a certain amount of money a year to a company called VeriSign. And VeriSign guarantee that that public key is Amazon's public key. And that way, you're completely secure in your connections to that server. If you don't have a trusted key, and it's not trusted with VeriSign, you get a little message that pops up. You've probably seen this, haven't you, sometimes? That basically means that key has not been registered with VeriSign. Okay? It hasn't been registered, so the browser doesn't know if it's a spoofed public key or the genuine public key. Okay? That's the difference. Now, when you're doing your work for your extension task, obviously we're not going to expect you to pay VeriSign for a public key. So you're going to use self-signing. So when you connect with your web browser, if this works properly, you'll get a message like this that pops up. Because the key that you generated won't exist at VeriSign. And this is how it works. This is the process of using SSL between the client and the server. So here's the customer, Amazon's customer, connecting to the website. And the first thing the browser says is, let's create a connection. Let's create an SSL connection. And it does that by connecting on port 443. That's the telltale sign. If you connect using port 443, it's telling the server, I want a secure connection, please. So the server then says, here's my certificate. Okay? Now, the chances are the certificate's already installed because it's gone through VeriSign. If not, it will pop a message up saying, this is a public key, do you want to accept it? Now, this is the clever bit. You send your public key using your private key on your browser. So in other words, you've taken the public key here, okay, and then you encrypt your key and send it back using the public key that you've just been sent. Okay, so you send your key across, and by using that public key, the server knows the customer's requested the connection. So you've got this lovely sort of handshake taking place. Okay, so the server decrypts the data and extracts your public key, and then it simply uses your public key to send the data back to you. And then your browser, which has its own private key, can then decrypt that data and display the web page. So you've got a lovely sort of dance taking place, haven't you, between the client and the server to make sure the connection's secure. And for your extension task, I'd like you to implement this on your Raspberry Pi. See if you can get this working. But basically, if you're doing an e-commerce solution or an API, the chances are the client's going to want SSL setting up, aren't they, to secure the data being transferred. So remember our basic HTTP authentication where we just did base64, didn't we? Username, password. Well, that's plain text, isn't it? Anyone could decode that and extract your username and password. So having a SSL setup is really important. And if your performance is an issue, what you do is you set up SSL just for the handshake and to authenticate. And then you would, you might, if it's just plain data coming across, which doesn't require authentication, you might use that over port 80 to speed things up. Basically, you know it's working if it's HTTPS, okay, as the protocol, which means HTTP over SSH. That's the shorthand for that. And you've got a little padlock in the browser. So that's what I want you to do for your extension task. To set up a self-signed SSL certificate and secure web pages using that certificate. If you really want a challenge, and the second bit, the virtual hosting, is you get a 5 by doing the previous bit. You don't need to do this last bit. This is just for those who really want a challenge. Okay? Virtual hosting. It's possible to host more than one website on the same server. Either using name-based virtual hosting, so if you know your host file in your computer, you put the host in. In theory, it's possible to have more than one host on the same IP address. So you can have Raspberry Pi and my website as two hosts in your host file, and if you connect to either of those two, you get different pages, different websites being served. The alternative is you can have two IP addresses on the same server, or the same IP address and two different ports on the same server to serve two different websites. You know, if you buy hosting for your website, that's how it works. You have one Apache install, but you have a config file which serves different web pages, different websites based on the exact URL being passed. So this bit is more for the sort of advanced user and those who want to have a play with this. But it is possible to set up both those systems on the Raspberry Pi with Apache. But for the assignment itself, I want you to limit yourself to getting the SSH set up properly. That's a big enough challenge on its own. Okay, now, you may get an error when you run your PHP script. The error is because by default, the eStrict is set up on your PHP config file, which basically means you can't use a variable without declaring it first. So for example, if you try and create an object that doesn't exist before and try and use it, you get this funny error. To fix it, just either change the config file for PHP, which is probably the quickest way, isn't it? And change eStrict, or just make sure you declare your PHP objects before you use them, and that will get rid of the. It's not an error; it's a warning. Yeah. References. Just to give you a hint, just to throw some extra stuff in there, I put a few packages in there for you, but you probably don't need those. Any questions about that? It's a challenge to get this working, especially the extension task, but you're well within your capabilities to do this. Next week, we're going to talk about setting up SFTP, so that's FTP over SSH, and also SMB, which is the drive protocol on Windows. So you can actually mount a drive on your home computer, on your computer, which points to your Raspberry Pi. So there's network drives. Okay. The following week, we're going to do a Git, look at how we create a versioning system using the Raspberry Pi. And the final week, we're going to play around with some shell scripting and start automating some of the most common tasks. And I'll also probably mention cron in the final session as well. Time-based activities. Okay? So a fun-packed couple of weeks ahead of us. Okay, thanks very much. Okay. Make sure you sign in, please. The registers